This is a look at lab equipment that you'll be using this year in biology and perhaps in your other science courses. So hopefully you're familiar with the beaker. This is a glassware piece with a wide body and brim and designed for holding solids and liquids. And because it has these numbers on the side, it is great for measuring liquids, right? Wrong! The body of the glass is really wide, and so it's difficult to get an accurate measurement. So, what would be a better tool to use? Da 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 da! Enter the graduated cylinder. So, because it is narrower in its body, then you get to have more accuracy as you read the different graduations or lines of the column. One thing to keep in mind as you are determining how much liquid is in a graduated cylinder, which you will do very soon, is you want to look at eye level at the cylinder, and the water is going to form what's called this meniscus. And it's not the meniscus in your knee. Some of you may have torn a meniscus in your knee, but in fact my mother did that snow skiing. I had to drive her to her surgery. So don't do that. But the meniscus of the water is where we have this concave or bent surface of the water, and we'll talk about the reasons for this. It's all about the molecular properties of the water, but basically in the middle is going to be the lowest point, and that, students, is where you want to read your measurement from, is that lowest point. This is what it looks like from an actual photograph. So you want to read from the actual lowest point and where it lines up with the graduation. Alright, next we have an Erlenmeyer flask. And this type of flask has a narrow brim and a wider body. And this is something that holds solids or liquids that may release gases during a reaction, or that may tend to splatter upon heating or stirring. So basically it keeps things contained a little bit better than a beaker would. The other thing that we'll take a look at here are test tubes and then the test tube racks, which we'll use to hold them. This is not a good idea, what you see in this picture, how the test tubes are just laying flat on the table. That will cause a breakage. If we were to have a breakage, remember that glass goes in the broken glass container upon talking to me about it first. But we do not want broken glass in the lab, and so one of the ways to prevent that is to place the test tubes in the racks. This is a really complex device with an intricate name. It's called a test tube holder. And this is for when your test tube is too hot to handle. You can squeeze the middle here and open up the clasp that will hold the tube. Alright, another really scientific term, test tube brushes. And obviously these are used to safely clean and thoroughly clean the test tube. These are going to be present within the cabinets of your lab tables along with some soap. And so we will wash our glassware anytime that we are using it. And also you want to make sure you have the appropriate size of the test tube to go with the test tube, because obviously if you try to place a big brush in a small tube, then we get back to that very undesired breakage of the glass. Alright, test tube rubber stoppers are to be able to close off whatever we have going on in the tube with whatever is in the air or whatever, to avoid contamination and so forth. This is a Bunsen burner, and we won't use this so much in biology, but if you go on to take chemistry, then you will use the Bunsen burner, which is connected with a rubber hose to the methane gas receptacles, which are at your table. And this is good for heating solids, liquids, and oftentimes we use a ring stand, which you see here with the clamps, to be able to put a piece of wire gauze over it, and then we put that whole setup over the Bunsen burner, and we're able to safely heat some sort of contents. This is something we will use a good bit this year, which is called hot plate, and this will be there will be a cord coming out, and an electrical cord which is going to convert electrical energy into heat energy, and this looks a lot like maybe what you cook with at home on your stove. And so something we need to really be sure of is that when we're not using this actively, it needs to be turned off using the dial, and then unplugged from the outlet. And on most of the hot plates that we have, there's a low, a medium, and a high setting, and so you'll need to pay attention to what setting you are needing to use for a lab. And then transferring of liquids, we're going to use either a medicine dropper or this is called a pipette. And this is for transferring small amounts of liquid, small volumes. On most of the pipettes that we have, when the liquid fills up to about the top of the shaft and not going into the bulb, we don't want it to go into the bulb. There's a line here which will tell you that that's about 1 milliliter of volume. And so that's a good reference point for that. And then lastly, just a little note of encouragement, don't let lab equipment anxiety put you under pressure. Just let me do it. This was a fun demo that I did with a physical science class one year, and so I basically shrink wrapped this student with a shop vac, and the idea is that we're all under atmospheric pressure. There's always this air pressure that is pushing on us that we're surrounded by. We don't realize it, think about it. But what I did was I used this shop vac to remove the air pressure from near this student's body, and that allows him to feel the full effect of the air pressure above him because the pressure now surrounding him is less than that immediately in this bag, and so he was just feeling really constricted. And so that was a fun demo. But don't feel constricted or stressed by lab equipment. Thanks for tuning in.